Good day and welcome to Shipping Insight TV. I'm Baba Waters, and I'm with my colleague, Huge Downs. Huge, what did you think of this past panel?
Good morning, everybody. Thank you very much, Barbara. Nice to work with you again.
Huge, what did you think of this past panel? What was the most
I'm
interesting
Huge
feature?
Downs. I thought it was fantastic, to be honest with you, but there's a couple of things that stick out in my mind. Number one is communications. Communications is imperative, all the way from from the operating mechanics all the way to the officers on board the ship. But the other thing is there's a disconnect when we're talking about safety and things like that. No matter what you're doing as far as optimization, if the officers on board that ship don't pay any attention to what's going on, we could have very significant casualties. I look back at the El Faro as one in particular. So it's a matter of using the information that is available through digitization and optimization and getting from one point to another, paying attention to the information that comes across.
Okay,
Thanks,
thank
Barbara.
you very much, Huge. And now we're going into our next deep dive and welcoming Dr. Ram Vis of Viswa Group, who will be the host of the next session.
I have my slides on the screen, please. Next one. Yeah. Okay, looking at the future. So there's light at the end of the tunnel. Yeah, next one. We all know that the Vlsophos fuels are here to stay. Almost 70% of the fuels are Vlsophos fuels. And there is a big percentage of MGO. And then HFO is only a small 8% of the fuel, high sulfur HFO. So the most vexing problem with VLSFO, as you all know, is the stability issue, and it's not easy because when you take the fuel in, everything is deteriorates. TSP values go up, and then you are forced to, you find that your purifiers are choking, your filters are choking. So the stability, which is the ability to stay stable during long-term storage, is not happening. So, from the Vishwa group, I can say that we have developed a proprietary algorithm based on PNA studies, paraffin, naphthalene, and aromatic content in the fuel. We are able to predict what will happen to the fuel and whether it is safe for you to bunker it for, let's say, 30-day usage or 60-day usage. And we also are in a position to recommend some additives which will help. Next one. So long-term storage is a big problem because this is completely out of the control of the fuel buyer. And because when he's buying a fuel which is in spec. But after 2 weeks, 3 weeks, he finds that it's gotten out of spec and he's experiencing all the problems. So how to solve the long-term storage problem, how to look at the sediment problem, how to look at the cold flow problems. These are all the problems of VLSFO, and we can't say that we have completely solved it. There are a lot of problems, and we need to address them and find solutions. The next one. Yeah. So what's the future scenario? In fact, this is the one that I wanted to start this thing. So IMO was afraid that this 2020 is going to be the Y2K of ocean shipping. This did not happen. Then they predicted a high spread between high sulfur fuel and very low sulfur fuel. That did not happen. And it was actually, they said $250 to $425, but it's kind of $50 to $60. So if it was high, then it was supposed to trigger a huge number of scrubber installation. Now, because the spread is only $50, $60, return on investment on scrubbers is 4 to 5 years, not at all attractive. So in the past 8 months, no fresh scrubber retrofit deals have been signed. There have been deals signed on new ships, but not any retrofit. So COVID has trumped all predictions, and COVID stopped the complete airline industry. 70% of the planes are idle, so there is plenty of jet fuel that is being pumped into the VLSFO fuel, bringing down VLSFO price. It's being added on to the distillate fuels, bringing down distillate fuels. That's the reason why VLSFO fuel and distillate fuel are almost at the same price. And jet fuel recovery will only happen when the airline industry recovers, and they're predicting another 2 years for that. US shale production has also shut down in big time. I'm not completely gone, big time shut down. So the only crudes that rule the market are the OPEC crudes. And many refineries have also been forced to shut down. So after 2 years, we hope things will return to normal, the spread will increase, and more scrubbers will be ordered. Then the lesson for us is experts made predictions. Ultimately, COVID called the shots. And here is a few parting thoughts in your mind. Next one. The GHG regulations are coming in even before these regulations have settled in. And carbon emission reduction, 40% by 2030, 50% by 2040. So the technology is being considered ammonia, methanol, fuel cell, hydrogen, biofuel from biowaste. And the industry itself is experiencing many new developments like blockchain and artificial intelligence, big data analytics, and unmanned ships. All these are going to make this industry nothing like what it is today and very, very different. The next person is Dr. Aparna Balachandran from Viswa Group. She's a director in that company. Go ahead, Aparna.
Good morning. Thank you. It's wonderful to be a part of Shipping Insight. And I wanted to thank Carleen for inviting me to present. Could I have my slides up, please? The next slide. I wanted to start off with a joke. There is a proverb, may you live in interesting times. I think we can all agree we live in interesting times. The next slide, please. On a more serious note, the topic I'm presenting today is 2020 VLSFO fuels. Specifically, what is the current situation? What are the benefits and disadvantages about this fuel? And what are the solutions to solve these problems? Next slide. First, let's define what an average VLSFO looks like, and can we truly characterize it? On the slide, you can see the average values for some of the ISO 8217 parameters. For example, the density is 936, the viscosity is 106. But if you look at the maximum values, these are much higher, and this represents a wide range of what is considered normal for the VLSFO fuels. The bottom line is that the VLSFOs are a heterogeneous group with lots of parameters that range widely, and they're all clubbed into one group. Next slide, please. Based on our testing of more than 50,000 samples in 2020, we found that VLSFOs account for 59%, distillates were 31%, HFOs 8%, and ultra-low sulfur fuel oils were 2%. You may wonder why distillates account for such a high percentage. There are many reasons, and some of the reasons include the crash in oil prices, the COVID, and jet fuel availability, as Dr. Vis had alluded to. Vishwa has done a lot of research and published white papers on the quality of VLSFOs, and we have put together a comprehensive compendium which covers all aspects of the VLSFOs. Next slide, please. So what are the benefits of the VLSFOs? The paraffinic VLSFOs have good ignition and combustion properties. Almost all the VLSFOs require a lower temperature for storage and during purification, leading to a lower heat requirement. The calculated gross calorific value is higher than the HSFOs, leading to a 5% increase in thermal efficiency. And only a few problems have been seen so far related to contamination from polymers, and this is much reduced, most likely related to the lower handling temperatures required for VLSFOs. Next slide. What are the disadvantages of the VLSFOs? If you look on my slide, on the picture, you can see that all of those fuels represent VLSFOs. This wide range of fuels all represent VLSFOs, which are made of multiple feeds in multiple blending ratios. And this may lead to some of the problems that we have seen. Long-term storage problems have accounted for almost 80% of the VLSFO related problems. There are two ways to identify them. One, which is a little more logistically challenging, is to let the fuel be stored and then tested prior to usage. And the second way is to do predictive modeling and proprietary algorithms prior to using the fuel and storing it. This can be done at Vishwa, and we can predict whether the fuel will stay stable for the long term or not. Some of the additives have helped if they're dosed adequately at the start prior to storage of the VLSFOs. The next most frequent problem that we noted was cylinder liner wear, which I'll discuss later. The third problem we saw was cold flow properties and wax formation in tanks. The important point related to this is pour point is required by ISO 8217 testing, but our data analytics showed that pour point had no correlation to the wax appearance temperature. So if the fuel could not be heated, wax formation could happen. And the key to remember in this is, in the unlikely and unfortunate situation that wax does form, the fuel has to be heated to a higher temperature, called the wax disappearance temperature, prior to being used. And finally, and probably most importantly, given the wide spectrum of the parametric values, the VLSFOs don't fall into a single grade in the ISO 8217. They fall into two discrete groups called the paraffinic and the aromatics, and treating them as one group is not correct. The next slide, please. So based on the problems faced by our customers and our experience, Vishwa has published these technical updates and white papers relating to these problems. Next slide, please. This is what problems with VLSFOs look like, with wax formation on the left and unstable fuel from long-term storage causing sludging issues on the right. The next slide, please. So to touch briefly on cylinder liner wear, what was noted was in January 2020, Vlsophos were used with a limit of 0.5% sulfur, and vessels started reporting an exponential increase in the cylinder liner wear. And this was quite puzzling to everyone. Next slide, please. The 8217 analysis indicated that the Vlsophos had met the specifications. Additional testing was done, and none of these indicated any abnormal parameters. So finally, Vishwa came to the conclusion that the damage to the liners was thought to be related to cylinder lubricating oil, both the quality, the quantity, and the failure to use the correct TBN cylinder lubricating oil to meet the reduced sulfur content in these Vlsophos. Next slide, please. I want to close with a summary of what I have presented. Vlsophos will probably be used widely in the near future. And given that they're a heterogeneous group of fuels, they should be used carefully and with a clear understanding of all their different properties. I wanted to thank you all for your attention. Thank you.
Yeah. Thank you, Aparna. Yeah, you exceeded by only 1 minute. So that's just to tell you we are watching the time. Okay. Peter, would you like to go now? Are you ready?
Well, good morning, everyone, and thanks to Shipping Insight for having us today, and to you, Dr. Vs, for moderating this segment. I'm looking forward to a great exchange of ideas today in this category. So like many of you, I've spent my entire career in the maritime sector, 35 years running now in marine, freight, and marine energy markets. And I just have to say I've been absolutely fascinated with the changes in the marine energy sector over the last 10 years when I've been trading in that field, in the marine fuels, which kind of prepared me for what I'm doing now, in a position to do something about the situation that our industry faces with energy and fuels and emissions. And really, it's our continued viability as a really critical sector of global trade. So we just got a few minutes each. I'll jump right in. On the topic of emissions and fuel, coupled with regulations and CO2 and warming implications, you start to run into a lot of numbers being thrown around. Let's look at the first slide. So since we're early in this conference, I'm going to take the liberty of just putting a couple of the key figures up here that have led us to where we are today. And you're going to hear these numbers being thrown around in different places this week. And hopefully this gives you a little bit of context. Historical observation has the world warming, a degree of Celsius over the last 100 years, with acceleration in the last half of that. And that's kind of what got people concerned. Within that, yes, there's anomalies of cooling periods within a longer term warming trend. With that, a sea level rise, and the scientific consensus has this really coming to a 3.2 degree, you can see that number, 3.2 degrees Celsius temp rise by 2100. And they're talking about the issues that come with it. Through the Kyoto and Paris Accords, they started to set some target limits. You'll see the next one that's to try to keep that 3.2 from getting there under 2 degrees Celsius, and a stretch goal at 1.5. So we note that all carbon, global carbon emissions, 30% of those are considered hard to abate industries, of which we're one of them, shipping, and we're 2.7% of the global CO2 problem. I want to just point out one good reading item here that I pulled some of these numbers from, and that's the Shell report that they did in conjunction with Deloitte, and I got a tag there for it. Just Google Shell and Deloitte and decarbonizing shipping. Very useful. Okay, let's go to the next slide. So bringing this home to our industry, there's a lot of good ideas out there, but very few clear pathways, at least today, to pursue, and a lot of compromises that come with those even. We got billions of dollars tied up in marine power plants and burning lower sulfur distillates and residual fuels. We just cleared a major hurdle this year with the IMO 2020 with the sulfur regs. We're still working out some issues with the replacement fuel to that, which is VLSFO. And Dr. Vs can give you a lot of information on that. We don't control the supply chain of energy, right? We've been historically buying the lower end of the hydrocarbon value chain in IFO, and we kind of have to take what we get. So this has been a hurdle, not just for us, but also for the people that produce the fuel, the refining industry. The IMO's focus over the last decade has been reducing sulfur, which has been helpful to human health, a little bit of environmental benefit, but now they're really kind of turned their attention to carbon. So you can see from baseline levels in 2008, the IMO is thinking about a 40% reduction by 2030. That's a pretty big first step. And then getting that up to 70% off this baseline of 2008 with specific breakout of 50% greenhouse gases. Now, there's a differentiation between carbon and greenhouse gases, even though one is the other. There are certain gas emissions that have a much higher weight, and you'll see a result of that later on. So let's look at some areas to focus on. Next slide. This is where work is already underway. We can look at hard technology advancements. We can look at the alternative fuels areas, less carbon intensive, all the way to carbon neutral. We can look at improving what we have now. And I'm going to spend some time on that. And of course, the last option is not really an option. Next slide. So touching on the first area, I mentioned about technology breakthroughs. So lots of capital and R&D has been spent and continues to be spent making these incredible, huge engines that power these ships. Advancements in turbochargers and injection systems have helped improve combustion, and we're even harnessing more of the heat energy that goes up the stack to power other shipboard needs that would otherwise be parasitic loads on the engine. Advancements in friction reduction, lube oils have helped save energy and extend the life of these big investments as well. So I don't have individual numbers for these things, but every single digit improvement that takes place in technology breakthroughs is going to help us get there. Keep in mind, we're heading for 40% in carbon reduction. Next slide. There's all kinds of other cool ideas that have been introduced, and in fact, some reintroduced. You see articles about hybrid power and LNG and the new propeller design and hull design. I would remind you that picture to the right, the bulbous bow, that's only a few decades old, and it was a big improvement in hull efficiency. Next slide. So the session after ours today is going to cover some of these specifically in depth. I just mentioned LNG, but there's also other alternative fuels that are being looked at much more closely, including hydrogen, either through combustion or through fuel cells. We've got ammonia, which is a large carrier of nitrogen, methanol and biofuels, and even nuclear. They'll get into that in the next topic. Let's talk about today. Next slide. What we can do now. So this was a quote from a major engine OEM. You see his name there from Cummins, testifying before Congress just a couple of years ago. It was an energy subcommittee. Basically, what he's saying is that the first and interim step to help reduce all the carbon emissions, particularly the dirtiest ones, is to make a diesel, what we're burning today, as clean as possible. But that begs the question, are we getting everything out of marine fuels that we can possibly today? Next slide. So theoretically, you can see that a drop of marine diesel or IFO has a finite amount of potential energy when it runs through an engine. How much of that can we harness by running it through an engine that has limitations right up front? You can see that 100% theoretical is truly going to be about 75 theoretical because of heat, friction, and inertia. Due to the nature of diesel combustion, the cycling of the RPMs, the varying loads, you can see what different modes of transportation that use diesel get today. The cars and trucks, because of the RPMs and the cycling, locomotives and tugboat engines are getting around the 35 to 40, and then large ships, two-stroke, slow-speed, large diesels are actually in the 40s and even approaching 50%. But that still leaves a 25% room to improve. So the question is, do we keep working on engine design with a lot of money and a lot of R&D, and which I recommend we do? But what about fuel? We haven't really talked much about that. And I would say that except for the sulfur that's come out of it, the diesel we're burning today is not that different than the diesel we were burning 10 and 20 and 30 years ago. What we burn is a function of what is yielded by cracking crude oil into diesel and IFO. So we're pretty much taking, like I said earlier, we're pretty much taking what we get, but there hasn't been a lot of innovation in terms of the diesel itself. That's what we're working on. Next slide, please. So with diesel, you hear about a couple of attributes of the fuel that have to do with its quality of burn and the injectors and the ease of combustion. Cetane and lubricity, two of the things that are in our product, but we've also added a third one, and that's a nanoscale cerium oxide that acts as a catalyst for oxidation. And that's really been the game changer for us. Let me show you what this looks like graphically in combustion. Next slide. For any of the engineers in the room, you might recognize this graph as a combustion plot layout with pressure on the left and degrees of piston stroke on the right and top dead center in the middle. Basically, the red line is standard untreated diesel. It starts ignition just before top dead center. It approaches a high peak of pressure and temperature during combustion, and then falls off quite rapidly as the fuel is expended. What we're doing with our cerium oxide catalyst, the Nano 2, we call it, is that the ignition is a little bit earlier. We don't allow it to reach quite a high temperature and pressure peak. You can see that green line being lower and slightly to the right, which actually prevents the formation of NOx. NOx gets formed at the highest temperatures of diesel combustion. But interesting enough, the catalyst then starts coming apart to donate billions of oxygen molecules in the back half of that combustion stroke, flooding all that oxygen in for more power duration and more complete combustion. You can see the delta between the green and the red line to the right of the peak. And that's really what we're doing. That gain there is about 10% more than the loss you'll see on the left side of the red line being over the green. We're just moving more of the power to the right in the stroke and not allowing that NOx formation and getting a more complete combustion. Okay, next slide. The numbers that come out of this are pretty noteworthy. This shows two independent tests, third-party tests that were done in controlled environments. One on a four-stroke engine, a smaller one that was done at the Houston Advanced Research Center, conducted at UT Austin, and then another one done at NRE Power Systems down on a dynamometer down in Houma, Louisiana, on an EMD 3,000 horsepower two-stroke. You see the upper white box is our fuel savings at different engine loads. You'll see those range anywhere between about 6.5 to 14% on the four-stroke and about 7.5 to 10% on the two. What's really interesting is the lower box shows you the emissions reductions that we notice. So particulate matter, or soot, if you will, it's in the 50s. Carbon monoxide, which is an indirect greenhouse gas, in the 17 to 30% area. NOx we measured on the NRE test at 20%, which is a big chunk, and the VOCs we measured on the four-stroke. Next one. So those two independent tests are the bottom of these rows, and then above that we've got actual field study tests that were done in our fracking and drilling and mining, coal hauling industries, as well as short line railroad. The first column you'll see was filled in for all of these, ranging anywhere between probably 8% all the way up to noted 17% in terms of fuel savings. Many of these industries, they enjoy the fuel savings, but the workload improvements are even better because they can take mechanical advantage, not just the chemical advantage of the combustion. Carbon monoxide reductions, anywhere between 37 and 60, NOx reductions, NO2 in this case, and then opacity. So in the field, we seem to do even better than in the lab, which is very encouraging. Next slide. I put this up here because we did a greenhouse gas calculation based on the NRE test I told you about in Houston. You can see that the biggest offender in diesel in the NOx category is the N2O, and that's got about a 300 times warming potential than carbon dioxide itself. So you try to get rid of as much of that as you can, and then start working on your CO2. If you calculate those out on a weighted average basis, nitrous oxide, carbon dioxide, and carbon monoxide, you end up seeing at the bottom there, we've got about a 15% reduction. So remember, we're targeting 40% by 2030. If these numbers hold, and they do, through all the different tests and all the different gases that we measure, this shows that we are about 15% towards the 40, which is a pretty big chunk right up front without any capital investment. Go ahead, next slide. So I'm just going to summarize real quick here, keep us in time. We know the global problem and the size, reducing carbon and greenhouse gases. Shipping is not a huge part of the global problem, but we are a single piece. 2.7% of the global carbon is probably over 50,000 ships. many of which are under control of people that are at this conference. A lot of different pathways that, we mentioned, the road signs there. The most immediate, we think, is to improve what we have today in terms of diesel combustion. We want to catalyze that diesel and get immediate results in greenhouse gas reductions. And my recommendation is that we work on all these. But certainly we want to do something today on our ships and our inland transportation, as well as the other industries. And we have a product that can help do that. So I think that's about it. I want to thank you again and turn this back over to Dr. Vs and address any questions.
Michael Lees, Chief Commercial Officer, Ultraclean from Australia. And you could start. Maybe you could introduce yourself and then proceed. Yeah.
Sure. Hi. Dr. Viz, can you hear me okay?
Yes, great.
Okay. Well, look, hi everyone, and thanks for making some time available for Ultraclean Fuel today. Just very quickly on myself, I've been working with the company since 2015, and we're a technology company that's been developing a solution to desulfurize fuels over the last 15 years. And we're applying that right across the fuel range now to separate high sulfur fuel products into low sulfur fuel products and asphalt. That's basically where we're coming from. If we can just then maybe go to the presentation. I suppose our interaction is more with the refining sector and traders. And what we were seeing, as was referred to earlier and everyone's very aware of, is if you looked at what was going on in the back end of last year, at that time we were catching up with refinery customers. The massive investment that was being made to produce VLSFO fuels was putting a lot of strain on balance sheets. One in particular that we caught up with, Kuwait Oil, had just finished a $16.5 billion investment in upgrading their refineries to be able to produce cleaner fuels. With that massive investment that you had across the refining sector, you then had a desperate need to recoup that investment. And you were seeing a ramping up in production of crude oil to generate the revenues, particularly across the Middle East, to pay for those refinery upgrades. That was, which would have been fine, but for what was coming next, of course. What you saw was the crude oil price starting to fall from December through to late April this year. And at the same time as the price was going down, of course, we had COVID-19 grip the world, which then was stalling demand for on-road fuels. As was mentioned earlier, what's that done? That's driven the oil industry to push products that are no longer, well, where the demand is weak on-road and for jet fuel into the marine sector, because the marine sector is at least one sector that is continuing to move forward. And what has that done? Well, you've then seen the knock-on impact with the refiners then output and redirecting fuels to the blending market. Blending, of course, has been a less than perfect solution, and as was mentioned earlier, you know, the issues that you're starting to see appearing in off-specification fuels. But this will be worked out, no doubt, as time moves on. But where are we at now? Well, we've got a situation where the spread that would have seen our company IPO and me probably retired by now, crashing from around 270 a ton earlier this year to, you know, around the mid 50s, 60s now a ton. But how long is it going to take to rebound? And I think we're expecting, from the feedback that we're getting from the industry, we're expecting that rebound to happen sooner sooner than we might think. And what that will do is drive the use of fuels back to where they belong rather than being tipped into the blending market. So if you look at where things are up to out there now, Chinese storage of fuel is starting to be drawn down. Gasoline demand is rebounding. And so what you're starting to see are the first green shoots of product pull, where you have, which is the first thing you need to see on the oil side of things, to see a shift we're going to see back to the impact on pricing, is that as those demands firm up, as storage is drawn down, we're then going to see a turnaround. We're expecting to see a turnaround in pricing. So I suppose from our perspective, what we're looking for is the redirection of diesel and gasoline and jet back away from the marine sector, and the impact that's going to have on the VLSFO price. We just go to the next slide. I guess the next slide then is sorry, Cross City AV. Are we onto the next slide there, the graph? Slide 2. Slide 3, sorry. Sorry, we're not to the right slide there. Anyway, I'll just keep going. So if we're looking at, well, I'm looking at now on slide 3, sorry, where you could see the compression in the price differential between the different products. So then I guess where we're coming from is, look, VLSFO, is it an opportunity, and who is it an opportunity for? So one view is that LSFO is a refiner, blender problem and opportunity. And the consequence of that is that it's the oil company, trader or blender that will capture the margin between HFO and VLSFO. Another view is that LSFO is a opportunity. And how do you access that? Well, through installation of a scrubber. But I guess
we have a minute. Yes.
Thanks. What we're seeing is a growing list of ports banning open loop scrubbers. Our view is that there is an alternative, which is to apply techniques to just desulfurize the fuel. So essentially what you're doing is, instead of going to a blended product, blended VLSFO product, you're starting with the HFO from a refinery, and then you're separating out the sulfur from that fuel. In our case, the way we're doing that is applying our proprietary technique, which is now on slide 5. And what we're doing is, as I say, we're just separating the high sulfur fuel into, I think what we've got is a differential in presentations between what Cross City AV is putting up and the material. But that's fine. I'll just keep going here. What we achieve is a reduction in asphaltenes, nitrogen, metals, which results in less precipitates. For every tonne of fuel, we have a 250 kilo reduction in CO2 versus existing refining technologies through application of a low complexity chemical process and a modular design that can be applied at tank storage. So our solution is to make available a technology that can be accessed whether you're a ship owner, a refiner, or a blender, or a trader, and that's our approach. Dr. Viz, back to you.
Thank you, Michael. I next invite Mr. Steve Benwell. He's a very senior accounts manager and global fuels with Infineum, which is one of the biggest additive manufacturing companies. I invite Steve to say a few words about himself and to comment on the topic.
Thank you, Dr. Vis. I appreciate the opportunity to come and talk to this esteemed group today. Hopefully I'll be able to catch you up a little bit of time here. I've only got a couple of slides to go through. A little bit of information about Infineum. For those people that don't know Infineum, it is a joint venture in the chemical additives business between ExxonMobil and Shell. Chemical divisions of those companies has been in existence for the last 20 plus years. It was JV back in 1999. And we're probably the only additive company that deals both with the lubes side of the business and the fuel side of the business. My job for the last couple of years has been to lead an activity on developing a range of fuel additives for marine fuels. We've had a range of additives for lubricants applications for several decades now, but this was seen as an opportunity for the company to develop products in this area. And historically, in the high sulfur fuel oils area, the amount of additive used in marine fuels was very low. But I think the opportunity now presents itself to bring forward additive technologies that can really make a difference in the way fuels are developed and used within the market. So if we can move to the next slide. So these are the kind of the 5 areas that were raised as areas of concern as we were moving towards the IMO 2020 regulations last year, or probably for the last couple of years. So availability, everybody was concerned. There were a number of studies that went on. Availability has turned out not to be a major problem. Now, this has probably been alleviated by the downturn in overall demand, et cetera, and the compression in the differentials between various streams brought about by COVID, as other people have referred to. And the bigger concern now is more around variability across various different fuels, as Dr. Anupam referred to earlier. But availability is really not a problem for the industry at this point in time. As things begin to come back, we'll have to see what happens there. Stability and compatibility, as Dr. Vis indicated right at the beginning, that was an area that was certainly anticipated as being a major problem. It has not been as severe as anticipated. But again, the impact of COVID and the availability of various blend streams into the marine area may well have alleviated this problem. And as that then turns around, we fully anticipate that other problems that the original problems that were anticipated will start to manifest themselves again. It's still an area of high interest and high concern, both for the VLSFOs and as a knock-on effect for some residual grades, because the high sulfur residual grades may get worse as a result of the fact that, in fact, you're not limited by 3.5% sulfur anymore. It's all based on what's your scrubber capable of handling. The specification parameters that are in existence today may need updating because they don't deal, as we believe, with the long-term storage issues that we're seeing. A fuel may be on spec for its total sediments performance on day one, but I've seen fuels that have gone from well on spec to off spec within a few days. And that's not picked up by the current specification parameters that we use today. So that's an area where I think that there's going to have to be significant more activity within the industry to do that. And we work actively within CMAC and also ISO to have an impact on those specifications. Waxing, this is the area that Dr. Anupam talked a little bit about before, where these fuels, because they are low sulfur, generally have more wax and therefore impact cold temperature performance. The existing specifications, again, may not be sufficient. Dr. Anupam talked about the difference between WAT and WDT, and the only specification we have in the VLSFO area is actually a pour point specification, which may not be sufficient to help the ship operators about how to utilize these fuels. And again, waxing is an issue both for the distillate grades and for the VLSFO grades within the ISO 8217 specification. Viscosity, this was a major concern to begin with. Operators do seem to be adapting to these lower viscosity fuels and are using less heating, although the systems that they have on board ship may not necessarily be sufficiently well tuned or capable of controlling the temperatures to levels that they need to. Fuel leakage has also been raised as an issue, whereby the very low viscosity fuels can leak more out of the systems, and that becomes both an economic but also a safety concern. And in terms of the ongoing work that we're doing, there are still some concerns with high wax appearance temperature but low viscosity fuels. You need to heat them to a higher temperature to deal with the high wax appearance temperature, but at the same time, you don't want to heat them because they are low viscosity to begin with, and that creates other problems. Combustion properties, this was expected to be better, but we have seen some issues around combustion properties. There is this impact on cylinder liner wear and scuffing and durability that has come up. There's been lots of speculation on the mechanism for that. I've seen people talking about it's a late combustion issue, it's a lube oil issue, etc., etc. There's no necessarily yet no unified mechanism as to why this is happening. So that just kind of covers the areas that were of concern and what we consider to be the current status. So if we could go to the next slide. So this is an area about what's going to happen now. What's the industry guidance in these areas, and where can additives help? So in terms of the stability and compatibility, the total sediments test is still only still the only real measure available of fuel stability. The TSP test is the reference. Guidance has been published by CMAC, and that has been well accepted by the industries. But some of the tests that people are using out there in the industry are just simply not suitable, and CMAC have pointed those out. In fact, if we can go to the next slide. Oh, there should be another slide after that. This is the list of tests that CMAC has said are suitable for assessing stability and compatibility of marine fuels. Anything that's not on this list, they have sort of said is not applicable for that. So this is just a reference for people. So we can go back to the previous 2 slides before. So additives can have a major positive effect on these parameters, but as Dr. Apana described before, they are best if added early in the fuel production and or blending process, because they have to work on stabilizing any asphaltenes or any insoluble materials early on in the process, because it's very difficult to reverse that process once it has occurred. It's not impossible. We have seen incidences where additives can do that, but it's way better if you can do that as early as possible in the process. And I would say beware of tests that use unrealistic solvent dilutions to enhance the apparent impact of the additive effect. There are some tests out there that can use solvent dilutions, heptane, toluene of up to 30 to 1 solvent dissolution. And that can show you some very good response, but we do not believe is applicable in the real world. So in the waxing area, ISO 8217 has already been changed for the distillate grades, recognizing the need for more performance. And so Cloud Point and CFPP are now reported requirements under 8217. And we're now seeing similar types of issues being recognized for some VLSFOs. There can be solidification between the wax appearance temperature and the pour point, and that's not good. For a ship, they can't use a product that has gone solid in the tank. Cold flow additives, of which Infineum is the largest supplier of cold flow additives in the world, can provide effective solutions for these marine fuel waxing issues. But again, there are lots of different types of fuels. There's not just a one-size-fits-all approach to that. In terms of viscosity, the industry guidance there's lots of guidance from the industry, from the various groups within CMAC, ISO, etc., about how to manage low viscosity fuels. But as I said, onboard systems may need upgrading for adequate control. we can move the viscosity of these marine fuels with viscosity modifier additives. Treat rates tend to be relatively high, but there can be other value drivers like the impact on leakage. We have lots of experience in this area from the lube side. And also cold flow additives can maintain a role of managing that delta between viscosity and wax appearance temperature trade-off. So that's an area where we're doing a lot of work with our additives in that area. Combustion, there's been some guidance from OEMs and CMAC, but the industry is still learning about these new fuels. These are radically new fuels from what were previously being used. Additives are likely to be able to help the liner issues, but we can deploy them either via the lubricant or via the fuel. And we're trying to figure out which is the best way to do that. But the other thing I'd like to say is that additives, I think, will be a major enabler for renewable liquid fuels and some alternative fuels into the future. So all the conversations about decarbonization, I think additives are going to be even more of a contributor to those developments as they go forward. So, this variable marine fuels quality is today's new reality. We've taken a bit of a dip. The demand for Vlsophos did go down. The composition of them was impacted by the upstream issues about refineries, and they've got more jet and everything. All of the lighter molecules are tending to be pushed down the column a little bit. Refinery throughputs are at all-time lows, which means that less of the residual content is being produced. But that will come back. We'll be back into an environment where the variability across the marine fuels will be back. We will see issues, and effective fuel additive technology is a key enabler to allow trouble-free operation in the marine industry.
Very interesting, but I think we've crossed the time by almost 3 minutes. But thank you for this, and please bear with me because we are supposed to finish this in 1 hour. We still have, I now request Sara to present her viewpoint. And
Good morning. So I guess this is quite interesting as we've had the different, as we've had the different perspectives brought together of the views of the testing aspects, what additives are out there, what our goals are. And I think as a bunker producer, a bunker blender, a bunker supplier, and then also the logistics, we really have a great opportunity to wrap all of this together. Next slide. I'm the managing director for Bunker One USA, and we started off as a relatively very small company. Since then, as a company of physicals, we have grown to operating in 22 locations across the world. Why do I mention this? Because it gives us a great deal of perspective of not only what's happening in our backyard, but what's happening across the shipping routes. Next slide, please. One of the things that Bunker One went out and did in the very beginning is that we didn't want to go out and be a vendor or a producer to just initiate in 2020. We needed to build out a very strong foundation, create diversity, and understand what the agility needs were, not for ourselves as a vendor, but for ourselves as a partner to the shipping industry. And I know during the whole 2018, 2019 speaking circuits, I'm sure that there are people that cringed every time I said, we're not here to be your fuel supplier, we're here to be your partner into 2020. But we really, really meant that, which is why we brought in the right people and went forward in establishing what our standards were and what our standards needed to be held within the industry. Next slide, please. That being said, we established our qualities, our consultancies, and then we created very important delivery mechanisms. And what do I mean by that? Meaning that our testing applications needed to be not only from the refineries we're partnered with, not from our storage, but all the way through cradle to grave. meaning that once it was delivered, we had control and consistency and tried to create that as a benchmark within the industry, which has worked very, very well for us. Next slide, please. Next slide. So as an industry, let's look at where we came from, and these have been touched on. It was a very well-planned transition. We were all concerned about what the avails were going to be, whether those avails were for a high sulfur fuel oil, whether those avails were for a very low sulfur fuel oil, to balance what the cleans for the marine gas oils were going to be, as well as the very low sulfur fuel oils across the board. There were immense amounts of models that were thrown out there of what the differentials were going to be, the cost savings. And because the market has been, markets are extremely efficient across the board, and then they also adapt to what your socioeconomics are, what your health world economics are, and the economies around the world. And that has been something that's been interesting to watch the refineries cut back on their crudes, which then obviously cut back on the very low sulfur fuel oils that are in the market. It has tightened it, and then it has also released it. And so it's been very, very interesting to see where 2020 seemed to be what many in the industry thought that the refineries were going to cash in on, the blenders were going to cash in on. And honestly, it has really been an interesting development of what the shipping industry's pricing mechanisms were, because it's really gone to a buyer's market. And the reason that I say that is because, and I'm not out here saying that you should be crying for the refineries or crying for the suppliers. It just ended up being a very different economic. But there's some dangers in that need to be taken into consideration, is that shipping costs in fuels, as you all well know, is anywhere between 20 to 60%. In this economy that we're in, which 2020, I'm sorry, but I read the small print in my contract for 2020, and I am not pleased with what we've been given. However, we are where we are. In industries, in the shipping industry, they're looking to be able to capitalize on what their cost basis is, how they move the most, and that's their job. What really needs to be important is all of the things that all of the speakers before me talked about, is that as a shipping industry, that we don't throw the baby out with the bathwater and go for the lowest pricing. These are some of the things as an industry across the board that we've worked towards, making sure that we have transparency in our quality, making sure that collaboration cannot be more important with our testing labs, with trends that we're seeing, compatibility testing, making sure that we separate our fuels from beginning to end so that we don't have the stabilities. But quite honestly, it's been very, very difficult as the economic turn that we're in of what we look for. Next slide, please. And again. So what do I think that the bunker industry and the shipping industry, which really are hand in hand, whether we want to be or not, that need to be taken into consideration? We need to look at where COVID is, because the world economies are changing and money makes the world go round. We fuel the ships that then make the products that are moved through our economies go around. And so we need to be aware of that, of what that imbalance in supply and demand is right now and how we move forward with that. The industry news that come out, there's going to be obviously increased credit focus as there's instability with the different companies. And so counterparties are extremely important. Also, the industry will shrink again. Why is all of that important, and why is this more of an economic discussion than it is about the deep dive? Next, please. If you look at the development since 2020, you can see where the demand is, you can see where the price line is, and then you can see where the shipping industry is. And again, if the shipping industry is not engaged with strong supply balance and strong supply quality, it's going to be a tumbling effect. And I'm sure that the testing labs can attribute to that. What seemed like a good idea at the time because of price ultimately did not end up with what they had anticipated. Next slide, please. Next slide. So On an overall basis, I think of all of these things that is the most important on this list is that it's about partnerships that are developed. These partnerships across the board, again, with our testing labs, with our engagement with the high quality of the crews, that people are finding that needs to be increased, of how they are handling it, with their involvement with their the hardware systems, and across the board. Those are probably the most important. Developing new products into the future. We're in the very beginning of the very low sulfur fuel oil. Now, as we are looking at what our next goals into 2030 and 2050, those communications and those developments are going to be even more important than ever. Next slide. All of that is common sense that's up there. One of the things that is most important is making sure that across the board, we have checks and balances. And again, many of my supplier counterparts probably would not be very thrilled with me having those statements, but it is extremely important for this checks and balances. These feedstocks that come off from different areas all have the different components that have been presented already. Making sure that we understand what those compatibilities are, and also having the transparency of not only from us as a supply partner, but from the vessels that we are fueling. And if there are problems, making sure that we're in those communications, not that we're just pointing fingers of this is your responsibility or this is your fault. I think that as an industry, we really continue to need to come together of having information shared instead of being competitive to the sides, that we need to come together, because ultimately we have a big challenge in front of us, whether it wants to be discussed or not. And so I think having this forum of the deep dive and what some of the challenges are from delivery to burning within the vessel is extremely important. Next slide. On an overall basis, there are going to be challenges. Challenges will always be there. When it gets difficult, that's when innovation will happen. If you look at where our shipping industries have gone, from wind to coal to fuel oils, and now into alternative fuels, the technologies that will be developed with artificial intelligence and the operations within our ships will become far more advanced than we've ever thought. And the trajectory of that is probably going to be more valuable than what I've been, a quote that was floated out with some of the alternative fuels symposiums that we've been. What's going to be developed in the next probably 10 to 20 years will be more significant than the development of the light bulb. And when you just kind of take a step back and think about that, we have a lot of work to catch up together as a group, not as individuals. So thank you very much. Thank you for all of the information that you gave forward, and we appreciate this forum.
Thank you, Sara. First of all, I would like to apologize to each and every one of you that we couldn't give you adequate time to express yourselves. And that's, I guess that's the way it has been set up. So please forgive me if I was pushing you. As it is, we are behind time. But this is, as Sara pointed out, a wonderful collection of experts here. And one is a new additive, another one is a very big additive company. Then we have Ultraclean, which removes sulfur big time. And then, of course, it's a very ethical and highly principled supplier. I don't think you can get a better collection. And also, some of these people are going to be with us forever because they put their name in it. Sara Shipman Myers. How can she ever go out of ships? Okay. And then Peter Lindsey, Purify Fuel. No, he's so they made sure that their name established a certain continuity and consistency with the industry itself. I just have two very brief comments. One is in one way we could have shortened the time is if this does not apply to everyone who spoke here, but if you just spoke about your expertise and what you have to say, not to make comments on the general industry condition, what will it be 5 years, 10 years, that will be covered over and over again all the time. Okay, I myself covered it.